Hello everyone, this is Khairul Alam Shobus from All Math Matters. Welcome to my online math class. Hello students, welcome to my another new online class. Today I am going to discuss about a very important topics for the O-level and A-level students, that is binomial theorem. Okay, in my today's lecture I'll try to discuss about all possible formulas and rules for the binomial theorem. Okay, first of all, what is the meaning of binomial? So binomial means two terms. That means if A and B are two terms, that means this is the binomial. Okay, so that means if there is two terms A and B, it could be any number, so or any letter, that is called binomial. That means it should be two terms. Okay, so before starting the binomial theorem, first we need to know the Pascal's triangles rule. Okay, so now we learn Pascal's triangle. So how it comes? So first we will try to expand this binomial term up to power 4, then we can see the pattern of this coefficient of the terms, and it looks like a triangle, and that's why it is called Pascal's triangle. Okay, so now if you look at the expansion of a plus b power 1, so it should be 1a plus 1b. Okay, now for a plus b whole square equal 1a square plus 2ab plus 1b square. For a plus b whole cube, it should be 1a cube plus 3a square b plus 3a b square plus 1b cube. So for a plus b power 4, we can write 1 a power 4 plus 4 a cube b plus 6 a square b square plus 4 a b cube plus 1 b power 4. Okay, so these are the expansion of a plus b power 4. That means up to 4 power 4. So now if you look at the first and last term, the coefficient of first and last term of each term are 1. Okay, so this is 1 and this is also 1. And if you look at there is, and this all the coefficient follows a pattern. How? If you look at 1 and this is 1, if you add 1 and 1, 1 plus 1, the middle term is 2. So if you add this again, 1 plus 2, that is 3, that means 1 plus 2, that is 3, again 2 plus 1, that is 3, again 1 plus 3, that is 4, again 3 plus 3, that is 6, so 3 plus 1, that is 4, and I told you that the first and the last term coefficient should be 1. So now I'll show this coefficient in a triangle form, that is called Pascal triangles. So for finding the expansion of given binomial term, we can use these Pascal triangles. If the question asks you to find the terms of 4th or 5th terms of the given expansion according to Pascal's triangles, then you need to do this. Okay, now I'll show the proper Pascal triangles. Okay, so if you look at the coefficient of power 1, that is 1 and 1, the coefficient of power 2, that is 1, 2 and 1, and the coefficient of power 3, that is 1, 3, 3 and 1, the coefficient of power 4, that is 1, 4, 6, 4 and 1. So now the coefficient, if the coefficient of power 5, then it should be the first term is always 1, and then 5, 10, 10, 5 and 1. So now if you look at the pattern of these coefficients, looks like a triangle, That's why this is called Pascal triangle. Okay, so we need to memorize this, because sometimes in question you need to find the terms according to this Pascal triangle. So we can make another. So what is the pattern of this? If you look at the middle of this term, so 1 plus 1, that is 2. So 1 plus 2, that is 3. Again 2 plus 1, that is 3. So here in every coefficient is follows some pattern. Okay, so 1 plus 3, that is 4. 3 plus 3, that is 6. Again 1 plus 3, that is 4. Again 4 plus 6, that is 10. And 6 plus 4, that is 10. Okay, and 4 plus 1, that is 5. 4 plus 1, that is 5. And all time the first and last term coefficient should be 1. So all these things are follows a pattern. That's why this thing is called Pascal triangle. Okay, now I'll show some example how we can use this Pascal triangle in the math. Okay, now I'll show some example how we can use the Pascal triangle for solving the math. Okay, so now if you look at it, number 1, so the question is use Pascal's triangle to find the expansion of number 1 2 plus x cube and number 2 x plus y to the power 5. So always keep in mind, if the power is 2, then the total number of terms should be 2 plus 1, that is 3. If the power is 3, then the total number of terms of this expansion should be 3 plus 1, that is 4. So here it should be 6. That's, and here I wrote the Pascal's triangles up to power 5. That means the total number of terms should be 6. That means this is the coefficient of this Pascal triangle. Okay, so now for finding this, number 1 2 plus x cube, so look at here, index equal 3, that means power equal 3. So the coefficient of the Pascal's triangle should be this. Okay, so now if we expand this, then we'll get, so that is 1 multiple 2 cube plus 3 multiple 2 square multiple x plus 3 multiple 2 multiple x square plus 1 multiple x cube. So here these are the Pascal, according to Pascal triangle, these are the coefficient for the index 3. So now if you solve this, then we'll get 8. So 2 square means 4, 4 3s of 12 x, and again it is 3 2s are 6 x square plus x cube. So that means if you now expand this up to index 3, then you will get this value, and this is the answer for this number 1. So in that way you can find the value of this by using the Pascal triangle. Okay, now I'll show number 2. Okay, now look at in number 2, that is x plus y to the power 5. So look at here, the index is 5. So that means the according to Pascal triangle, the coefficient should be this row. Okay, that is the 5th row, 1 5 10 10 5 and 1. So now if we expand this up to 5, then it should be 1 x to the power 5 plus the coefficient should be 5 x to the power 4 into y plus 10 x cube y square plus 10 x square y cube plus 5 x y to the power 4 and finally y to the power 5. Look at the 5th row according to Pascal triangle, that is 1 5 10 10 5 and 1. These are the coefficients. So these are the coefficient according to Pascal triangle. So now you just work out this thing, then you'll get the answer, that is x to the power 5 plus 5x to the power 4y plus 10 x cube y square plus 10 x square y cube plus 5 x to the power x y to the power 4 plus y to the power 5. So this is the expansion of x plus y to the power 5 by using the Pascal triangles. Okay, so these all about the Pascal triangles. So in that way you can easily find the expansion of the given binomial term. Okay, so that's why you need to memorize this Pascal triangle, and by using this pattern you can make any number of row. You can make another row, that is 6th row, then you just add 1 plus 5, that is 6, 5 plus 10, that is 15, 10 plus 10, that is 20, 10 plus 5, that is 15, 5 plus 1, that is 6, and the first and last coefficient should be 1. So in that manner you can make any row from this Pascal triangle, because all the rows follows a pattern. Okay, now I'll show the binomial theorem. Okay, now I'm giving you the formula about the binomial theorem. So let's say a plus b power n. So here power is n and n should be positive. Okay, so now you must need to know the binomial theorem. Okay, now what is the expansion of binomial theorem? So the theorem is a power n plus nc1 a power n minus 1 into b plus nc2 a power n minus 2 into b square plus nc3 a power n minus 3 into b cube plus, if we look at in general terms, that is NCR a power n minus r into b power r up to b power n. So if you look at, this is the general term. Okay, and you can say this is the r plus 1 term of this expansion, that is the for the binomial expansion, and this is the important thing you need to know. Okay, so if you look at here also some pattern, so the power of a is decreasing and the power of b is increasing. Okay, so if you look at the power of, in the first term the power of a is n, in the second term n minus 1, n minus 2, that means it's decreasing, and in the first term there is no b, but in the second term that is b square, that means the power of b is increasing and the power of a is decreasing. In that way the terms are coming one after another. Okay, so here the most important things for the binomial theorem is you need to know the r plus 1 term. Okay, so that is r plus 1 term in the expansion of a plus b power n is NCR a to the power n minus r into b to the power r. So this is the r plus 1 term. Okay, you can say this is tr plus 1. So by using this term you can find anything from this expansion. Okay, and you should keep in mind this here. So here you need to know something about the NCR. What is the NCR? Actually here C for combination. Now I'll show some formula of NCR. Okay, now here the NCR means n factorial divided r factorial multiple n minus r factorial. Okay, so this is the formula for NCR, that is here C for combination. Okay, so now you can learn some properties of this formula, that is some corollary formula from this expression, that is NC0, so it should be 1, and NC1 it should be n, NC and NCN it should be 1, and here you also can memorize something, or you can try to get the idea how you can find the value of this. So if it is NC2 you can say n multiple n minus 1 divided 2 factorial. Okay, so in C3 it should be n multiple n minus 1 n minus 2, that is 3 term, first 3 term divided 3 factorial. So in that way you can easily find the value of, let's say, 5C2. It should be 5 multiple 4 multiple 2 factorial, that is 2, so it should be 10. Okay, in that we can find the value of this combination without using the calculator. But if the numbers is so large, then you can use your calculator, because the formula is given on your calculator. You can use the calculator, you can find the any value of NCR. Okay, now I'll solve some problems for binomial theorem. Okay, now I'll try to solve some problems by using the binomial theorem. Okay, let's say some problems will be like that. Use the binomial theorem to find the expansion of number 1 2x plus 3y to the power 4, number 2 x square plus 1 by 2x to the power 6. So here you just need to use the main formula of the binomial theorem. Okay, so first, for the first number 1, okay, so that is 2x plus 3y to the power 4. So if you look at the formula, that is a plus b power n, this is the general formula. So if you compare with this, so here it should be a, it should be b, and that should be n. Okay, so now if we expand with the binomial theorem, then it should be 2x to the power n, that is 4, plus nc1, that is 4c1, multiple 2x to the power 4 minus 1 into b, that is 3y, plus 4c2 multiple 2x to the power 4 minus 2 multiple 3y square, that is b square, plus 4c3 multiple 2x to the power 4 minus 3 into b cube, that is 3y whole cube, plus 3y to the power 4. So this is the main formula for the binomial expansion up to power 4. Okay, now if we work out this by using your calculator, so 2 power 4, that is 16x to the power 4, and here 4c1 means 4, multiple 2 power 4 minus 1, that is 3, that is 8x cube, multiple 3y plus 4c2, that is 6. By using the calculator you can find it quite easily. Multiple 2 power 4 minus 2, that is 2, 2 square, that is 4 x square, multiple 3 square means 9y square, plus 4c3 means 4, 2 power 1, that is 2x, and 3 cube means 27 y cube, and finally 3 to the power 4, that is 81 y to the power 4. Okay, now if you now calculate this by using the calculator, then you will get the expansion of this. Okay, you just multiply this 4 multiple 8 and multiply with 3, then you will get the coefficient, and it should be x cube y. So in that way you can easily find the expansion of this. Okay, so this is the expansion for number 1 up to power 4. Now I'll show number 2. Okay, in number 2, that is x square 1 over 2x square power 6. It doesn't matter, so it doesn't matter, it could be anything in the place of a and b. Okay, it could be fraction, it could be any number, so you just follow the formula. Okay, so here a is x square, b is 1 over 2x square, and here the power n is 6. Okay, so now if we expand this, then we can see that is x square power 6 plus 6c1 multiple x square power 6 minus 1 multiple 1 over 2x square plus 6c2 multiple x square to the power 6 minus 2 1 over 2x square power 2. Next is 6c3 multiple x square power 6 minus 3 multiple 1 over 2x square power 3, it should be square, plus 64 multiple x square power 6 minus 4 multiple 1 over 2x square power 4. Next n65 multiple x square power 6 minus 5 multiple 1 over 2x square power 5, and finally 1 over 2x square power 6. Now it is looking so complicated, but if you look at the theorem step by step, then it will be so easy. But in general, if you look at just, then you can find it so complicated. Okay, but you should here use the formula step by step, and there is a pattern. Look at here, 61 and here is 1 and here is 1, 62 here is 2, here is 2, 63 here is 3, here is 3, 64 here is 4, here is 4, 65 here is 5, here is 5, and the last term should be power 6. So in that way you can easily find any expansion of the binomial term. So now you need to calculate this, and if you work out this, then you can easily find the expansion of this term. Now you can work out this at home, then you will get the answer. Okay, now I'll show more examples and more sums from binomial theorem. Okay, now another example for binomial theorem. Okay, now here look at the question is, find the coefficient of x in the binomial expansion of x negative 3 over x to the power 7. Okay, so here now if you if you look at, this is power 7. So for finding the coefficient of x, now if you expand this according to the main formula, I think it will be so complicated, and you need to calculate all, and then you need to expand all the terms, and you need to search where the coefficient and where the power of x is 1, and I think it will take more time and it will be so complicated. But if you use the general formula, that is the r plus 1 term, then you can easily find the coefficient of x. So now look at the solution. Okay, so for finding the coefficient of any power or anything, you just always consider the coefficient of x is exist in the r plus 1 term. Okay, so let the coefficient of x in the binomial expansion of x negative 3 over x to the power 7 is exist in r plus 1 term. Okay, so here just I am writing clearly, or you can write it shortly. So now we need to find the r plus 1 term of this expansion of this. Okay, so we already know the r plus 1 term for the general formula, that was r plus 1 term was NCR a to the power n negative r into b to the power r. Okay, that was the r plus 1 term for the binomial expansion. So look at here, a is x and b is negative 3 by x. So always keep in mind, if here the sign is negative, you must consider this as a negative for the b. Okay, otherwise the answer will be wrong. Okay, now look at here the r plus 1 term equal what? N means here, n means 7 CR x to the power 7 minus r multiple 3 over x to the power r. Okay, so here you just try to do some workout and take the all power of x together, then it should be 7 CR x to the power 7 minus r multiple negative 3 to the power r, or you can say x inverse r. Okay, Okay, now if you look at by using the exponential rules, so you can say it is multiplication, the power should be addition, that is x to the power 7 minus r, and multiple negative 3 to the power will be remain same, so 7cr into x to the power 7 minus 2r multiple negative 3 to the power r. Okay, so now look at here, the power of x is 7 minus 2r. So we consider that the coefficient of x must be in this r plus 1 term. That means the power of x is 1. So if the power of x of this term is 1, then our assumption will be correct, otherwise it will be wrong. That's why we can say this equal 1, and by using this condition you can find the value of r. Okay, so now, and here you can write a statement, since the coefficient of x exists in r plus 1 term, so the coefficient of the power of x to the power 7 minus 2r should be 1. So that's why you can write here 7 negative 2r equal to 1, or you can write 2r equals to 7 minus 1, or you can say r equals to 3. So now it is so important, here the value of r is 3. Now you can easily find the coefficient of x. So now coefficient of x means, so now if you put here r equal 3, look at 7 minus 2 into 3, that is 6, 7 minus 6, that is 1, that means x. So the coefficient means except x, the all terms in this general term. Okay, so now here the coefficient of x is what? R equal 3, that is 7c3 multiple negative 3 power 3. So you can use the calculator. If you use the calculator, it should be 35 multiple negative 27. Now if you do the multiplication of these two, then it should be 945, negative 945. That means the expansion of x negative 3 over x to the power 7, the coefficient of x should be 945, negative 945. So look at, by using this general rule, it is quite easy. Okay, but if you use the main formula, that means if you use the expand this whole term, then it will be so complicated and it will be so time consuming to find the coefficient of x. Okay, I'll show more example for this binomial theorem by using this general term. Okay, now look at in another example. So find the example is find the term independent of x. So this is the important thing, that is term independent of x. That means in the term there will be no x. Okay, in the binomial expansion of this. Okay, so now here look at, here the power is 9. So if you do this by using the main formula, it will be so long and so complicated, because it will be 10 terms and that will be long calculation, and it will be difficult to you find the term independent of x. Okay, and it will take more time. But if you now use your general formula, that is the r plus 1 term, then it will be so easy for you. Okay, so term independent of x means here here is no x, that means the power of x should be 0. Okay, now look at the solution. Okay, now just consider let the term independent of x exist in r plus 1 term. Okay, so now we just find the r plus 1 term by the expansion of this. Okay, now r plus 1 term by the expansion of this, then it should be 9cr x to the power 9 minus r, and here b is 1 by 2x squared, that is 2x squared to the power r. So same thing, we just separate the power of x here. So 9cr x to the power 9 minus r, it should be 1 by 2 to the power r, x inverse 2r. So by using the exponent or indices, then you can say x to the power 9 minus 3r multiple half to the power r. Okay, so now look at here, the power of x should be 0, then our assumption will be correct, otherwise our assumption will be wrong. So we just consider this power should be 0. By considering this, we can find the value of r. So if you now find the value of r, then you can find the term which is independent of x. Okay, I think this is so simple by using this general rule. And if you now look at, so now you can say therefore 9 negative 3r should be 0, or you can write a statement, since the term independent of x in the binomial expansion of this exists in the r plus 1 term, so therefore 9 minus 3r equals 0. I just write it in short. So you can say 3r equal 9, or you can say r equal 3. Okay, so now we got the value of r. Now it will be so easy for you to finding the term independent of x. That means there will be no x, you just put the value of r here. So now the term independent of x is, just put the value of r, that is 9c3 multiple 1 by 2 power 3. Okay, okay, now if you use your calculator, then you will get the value of this. So here 9c3 should be 84 multiple 1 over 2 cube, that is 1 over 8. So now if you do the calculation by using and dividing by 4, then it should be 21 over 2. Okay, so this is the value of this, that means the term independent of x here. So where there is no x, that should be 21 over 2. Okay, this all about the basic things for binomial theorem. So just in my today's lecture, I had tried to show some basic formula and basic example of binomial theorem. But in my next lecture, that means in part 2, I'll try to show some more formula for binomial theorem. That means if the power of n should be the negative or fraction, then what will be the theorem? And and also I'll try to solve some past paper question in my next lecture. So class, thank you everyone for watching this lecture. So please subscribe my channel to get the next lecture, that means in part 2 of this binomial theorem.